This video is a continuation of compound interest. So before we go further, let's review. Simple interest is calculated from the principal amount. So either how much you're taking out on that loan or how much money you're depositing into a savings account. Since it's calculated only from the original, it stays the same over time. Compound interest, however, is calculated from the most recent balance. So that's the biggest difference. Compound interest allows you to earn interest off of your previous interest. So this graphic below shows that if you start with $100 and you get 2% interest, the first year you'll get $2. But the next year, they're going to recognize that you have $102, so they'll recalculate your interest and you get a few more cents. That'll happen again the next year, where now you have $104.04, so you still get a few more cents. Banks can actually recalculate your interest more than just once a year. So in this video, we're going to look at what does that look like and how can we adjust our formula accordingly. So the first thing we need to start with are some key vocab terms for recognizing that it's more than just once a year. So the three biggest ones are annually, semi-annually, and quarterly. So annually is actually what we have been seeing. The word annually means just once a year. So once a year. Quarterly is probably one that you'll know right away. Quarterly means 4 times a year. And semi-annually means twice a year. You might be pretty familiar with these terms already because you see them outside of math class. These are also good terms to write down in your notebooks, so go ahead and pause this video so that you can get these down before we continue. So if you remember, we had some differences between the simple interest formula and the compound interest formula. The biggest difference is that the entire formula is set equal to your final balance instead of just the amount of interest you earn, like in simple interest. The other two major differences were actually what the R stands for, and then we used N instead of T. Last class, we looked at using N just the same as the number of years, but this is where it starts to become different. N actually means the number of interest periods. So think that if it was compounded twice a year for 2 years, that would be 4 total periods that they would recalculate that interest. So it's no longer the same as just the amount of years. R actually stands for the interest rate for one period. So if they do give you 6% twice a year, they don't actually give you 6% 2 times. They'll split that in half and give you 3% each time. So as you can see, there's 2 slight changes that we need to make before we start using the formula with the numbers as they are given. So we have to change R and N before we're allowed to plug it into the formula. In order to change R to account for just the amount of that rate that you're getting for that one particular interest period, you're going to take that rate, and we're still using decimals, and you're going to divide it by the number of times per year. So like I said on the last slide, if you were to get a rate of 6% compounded twice a year, you would take that rate, 6, as a decimal, 0.06, and divide it by that 2 for twice a year. That's the number that you would plug into your formula. For N, that actually is getting bigger because it's the total number of interest periods. So you're going to take your years, and this time you're going to multiply it by the number of times a year. So in that last example, if it was 2 years twice a year, you would do 2 times 2 and use 4 in your formula for N. So write these 2 things down in your notebooks. Pause the video if you have to. But again, the rate you are dividing by the number of times per year, and the N you are multiplying by the number of times per year. So the first example that we're going to look at states you invest $750 in an account that earns 4.5% interest compounded semi-annually. So that's that key word that's telling you it's more than just once a year. Then the question says, find the balance of the account after 2 years. Round your answer to the nearest cent. The first thing you should do is jot down the numbers that you're going to use for P, R, and N, especially since the R and N we're going to have to make some slight adjustments for since it's semi-annually. The principal amount is just as it's given, that's $750. The rate as it's given right now is 0.045 and my years are 2. I'm not going to use 0.045 and 2 though because I need to make my changes first. So remember my rate, I divide, and the N, I multiply. So semi-annually means twice a year. So for the rate, I'm going to divide by 2, and for the N, I'm going to multiply by 2. Again, that 2 comes from the fact that it's semi-annually, which means twice a year. So the real value I'm going to use for R in my formula is going to be what 0.045 divided by 2 is, which is 0.0225. And for the N, I'm going to use what 2 times 2 is, which is 4. So these are the numbers that I'm going to be plugging into my formula. The good news is the formula is the same as what we used when it was just annually. So B equals P times the quantity 1 plus R, all to the nth power. So when I go to plug these in, I'll be doing 750 times 1 plus 0.0225, all to the 4th power. And plugging that into my calculator gets me a final balance of $819.81. In our last example, it says you deposit $1,000 that earns a 6% interest rate that is compounded quarterly. If you let it sit for 5 years, what's your total balance? So again, starting out by just making a list of what I'm given. My principal is $1,000. My rate right now is 0.06, and I let it sit for 5 years. I'm going to make adjustments to these two, my R and N, dividing the rate and multiplying the N. This time, since it's quarterly, and that means 4 times a year, I'll need to divide my rate by 4 and multiply my N by 4. So the actual values I'm going to be plugging into my formula are 0.015 and 20. Back to my formula now. I'll be plugging in 1,000 times 1 plus 0.015, all to the 20th power, which gives me a final balance of $1,346.86. You'll be practicing these on your own now, so feel free to come back to this video whenever you need a quick reference.